Well, morning, everyone. I'm delighted to be here today. It seems like everyone's really beginning to recognize the value of observation data in finance and insurance and other sectors. I'm excited to speak here. The planet, we set ourselves the mission of imaging the world every day when we left NASA about 6 or 7 years ago. And for many years, we have spoken to people in the finance sector and other sectors, and there was a lot of blank faces for some time, and now there's a lot of interest, and I think that it's growing excitement. So Roger said that we need data, well, we've got lots of that. But actually, as we will explain, I think, and see throughout this day, it's more than just data that one needs to solve these problems. One needs a lot of analysis on it. We have a deluge of data, but we also need to really probe it and understand it with analytics. But at the same time as the avalanche of new data is coming down from a new suite of satellites, we are really seeing a changing landscape of analytical capabilities with the advent of AI and particularly computer vision. So I'll be talking a little bit about the satellite side of it, and we'll talk more about the other aspects during the day, I'm sure. So we set ourselves the mission when we left NASA of imaging the entire Earth every single day with a large new fleet of satellites that it would take to do that. We believe that data set would have a large number of use cases across humanitarian, commercial, and government uses. We have spent a lot of time and a lot of energy launching a lot of rockets, 25 so far, and we now collect, having launched the largest fleet of satellites in history, about 1.5 million images on the Earth every day, representing 350 million square kilometers. So the land area of the Earth is 150 million square kilometers, so just over double the land area of the Earth each day. We mainly focus on land, but we do some of the waters. We put ground stations around the world. We process all this data. It was a minor Apollo project to get to this point, but now we have daily imaging. This is one of our rockets. This is how we get there. We put our satellites on any rocket going roughly in the right direction. We stuff them on the side and we spit them out. Here they are being spat out. And if you haven't seen anything like that, that's because no one ever did do that crazy things before us. In fact, we just had 3 launches in under 30 days over the Christmas break, culminating in this Soyuz, which is a beautiful picture of the Soyuz. But we also had a SpaceX rocket and a PSLV rocket from Russia. This one took off in minus 28 degrees weather, so we've got it balmy here in London today in comparison. This is how the satellite fleet works. We actually put them all into one polar orbit, so it's a ring, like a ring of a string of pearls around the Earth, and each satellite takes a strip of images as it goes down around the planet. But the Earth conveniently rotates underneath, such that we end up line scanning the planet every 24 hours. We also have a set of slightly higher resolution satellites called SkySats that we inherited kindly from Google, which can zoom in at higher resolution. They can't scan the whole planet each day, but we can zoom in and take higher resolution snapshots of locations that we want to zoom in. So we scan the whole Earth at 3 meters resolution per day, and then we can zoom in at 70 centimeter resolution where we need to have slightly more details, especially in urban areas and so on. This is what our fleet looks like. So we have just over 130 satellites of the medium resolution variety and 15 of the high resolution variety. This is a lot more satellites than anyone else bothered to put up because we are slightly crazy. This is what our imagery looks like. So this is of our hometown in San Francisco, where we're based. And so the imagery is at 3 meters per pixel. You can see a building, you can see a road, you can see a ship, you can see a plane, but you can't see a person. You can't, read the number plate of a car or something, which is James Bond territory, by the way. Not in practice, anyone can do that, because we're 500 kilometers away, and our satellites are yay big. This is actually not a scale model. This is the life size one. It's not a real satellite for various security reasons. We can't bring one here. But they weigh about 4 kilograms, and that thing is 500 kilometers away from its target and taking pictures of the ground. So I'm always amazed that we get even images like this when we're taking pictures like that the optics are extremely good that we stuff inside of our little satellite. And increasingly, the sensor systems that we put around those optics are incredibly sophisticated too. We can now get data down from our satellites at over a gigabit a second when they're 1,000 kilometers away, which is also remarkable to me. The advances in radio technology are really quite fantastic too. The real bottom line is we're stuffing the latest and greatest technology into these little boxes, and although they look like a toy, they are certainly not. So that's what our imagery looks like. But the key thing is that we image the whole planet like that image every day. And in fact, in each location on the Earth's surface, we now have a deep stack of images, of over 800 images on average for each location on the Earth's surface, which enables one to train models of what is changing over time on the Earth's surface. Then our high-resolution imagery looks like this, and my colleagues have kindly found one of this place and pointed out our building. So you are here. And at that resolution, you can see a little bit more detail, and, like how many crates are on the ship, or what are the detailed lane structures of the cars. And you'll notice that things that are moving you start to have a rainbow color effect, and that's because the timing of each band is slightly different on the satellite. So moving objects are a little bit of blur, and that we can actually tell the velocity of those objects from that. We can also, as it happens, do video. This particular one is taken of over Windsor Castle the day that certain people got married, but it doesn't seem to be playing, so I'll carry on. Some of the use cases of our imagery is because it's quite wide-ranging, not just in the finance sector. There's a wide range of uses for government, ranging from security and understanding ports security and maritime security, civil government in areas of disaster response, and I'll show a few examples of that. Our biggest client base is at present time in agriculture, actually. 25% of the land area of the Earth is agricultural land, and we can help improve crop yield by telling crop type and crop yield in each pixel through a near-infrared band that we have on our satellites. We actually tell biomass, so basically chlorophyll sticks out like a sore thumb in near-infrared, and we can use a certain calibration data set to tell crop type and crop yield pixel by pixel, so we can say this is wheat and this is how well it's doing on a worldwide basis, and that gets us into the sort of financial applications, especially on commodities, like on agricultural commodities. We can then, of course, say how well the wheat market is doing, or whatever that commodity, and not just agricultural commodities. You can also imagine tracking how much oil is in all the world's oil drums, and in fact, we did an analysis of oil drums with our partners in China, and found that there was twice as much oil in reserve as the market had understood in the oil drums over there. So that kind of information could be valid and interesting for financial services. We'll talk about some of the insurance use cases, but especially around disaster response. We have imagery before and after disasters, and so that's of interest. Forest management is another one. We care about both deforestation tracking, so on the humanitarian side, but also forest management on the commercial side. And then in the top right is just the mapping use case. So we do sell our data to companies like Google, who use it to update the satellite imagery layers that you see online. So that's some of the wide variety of use cases. There's some geopolitical relevance of our data too, and some of the news media pick it up. I was just at the BBC yesterday. We were talking about this particular case on the bottom right, when then there was the volcano in the island in Indonesia, and the before and after images of that. We were the first ones to snapshot that from space and see what happened, because of course it was all evacuated. Slightly more recent example, here's a certain area of Brazil just a couple of days ago, and here's just afterwards. So this is the mud slides and flooding that has occurred after the dam broke just a few days ago, and unfortunately, a lot of lives were lost. In this sort of situation, we provide our data for free to the disaster response agencies in the relevant countries and certain NGOs. But it's also true that this is relevant for insurance companies who both might be able to assess how that dam is, whether it's vulnerable to this sort of catastrophe in the first place, but then certainly the analysis of insurance claims in the aftermath of such an event. The bottom line is you can't fix what you can't see. You know, I'm a physicist by background, but there's a strong engineering principle, which is that if you don't take data on a time scale faster than your thing is evolving, then you can't do anything about it. So we send these satellites into space, and they have lots of challenges often. Say, for example, they go into a spin, and we didn't want that spin, and say that spin is at 1 hertz. If we take data every 10 seconds, well, we're not going to be able to figure out how to stop the spin. The same is generally true about us steering and helping with what we call the spaceship Earth, this large spaceship with 7 billion astronauts on it that hurtles around the sun. And we need data on how it is evolving if we are going to take care of that spaceship. And we need to have that data on a faster timescale than our human activities around it. And that's really the bottom line of why we started Planet. And I really hope, despite recent trends, that we are entering into a truth economy, because these pictures don't lie. They are what they are, and it sort of tends to lead us towards a transparent planet of what's going on that we can all look at. I'm going to just talk about a few more examples here. This is some of the work we can do in tracking refugees and other civilian crises that we work with Human Rights Watch on. Obviously, there's deforestation, a tragic amount of deforestation that we see under and before our eyes. And by the way, this was actually the development of also a gold mine in a preserve in Peru that was found with our imagery. And the reason it was found was that people were dying of lead poisoning further downstream, and they were like, where's all this lead coming from? We looked upstream, and there was this big gold mine, mining facility. So let's talk a little bit about the Sustainable Development Goals, and I think it will illustrate a few more kind of use cases. So we looked at the Sustainable Development Goals when we started Planet to think about which ones we could help. I mean, we were basically space geeks trying to figure out how we could save the planet. And we really thought that daily imaging could help a number of these goals, and we did an analysis that we can help 12 of these 17 Sustainable Development Goals. I'm going to give a few examples. So the first one is related to poverty, and we can track refugee camps as they grow, and poverty intrinsically relates to that. The next one is on food security, and we can help improve crop yields, not just for the large agricultural companies in the West, but also in developing countries too, and help food security. We can help, the next one's on water security, and there we can tell reservoir levels of every reservoir around the world every day and help water management. Obviously, a lot of the ones to do with climate change, we can help monitor. This is flowing ice fields. And this is a whole bunch of carbon, of deforestation. And here we're not just trying to see when a tree goes down, and we can see every tree on the planet each day and track if one goes down, but moreover quantify the carbon economy that needs to be measured in order to hold countries accountable to the Sustainable Development Goals. A new thing that we're getting a little bit more into is tracking efforts of stewardship of our oceans. So we did a big project with the Vulcan Institute and the Carnegie Institute of Science on understanding corals around the world. So we did the first high-resolution base map of all the world's corals. And not just did a base map, but started work with these scientists on identifying the different classification of different parts of the coral system, and then also, and importantly, monitoring them day to day to see if there's any illegal fishing or other trawling or other activities that would otherwise disturb those coral systems. So we can help detect that. And then in terms of life on the land, we can help with disaster response related to fires. This is a really recent case of the fires in California. This is showing our near-infrared band, false color image. The near-infrared is shown up in red, and you can see the devastation of where the fire was, that there's almost no live matter there anymore. With fires, we can help understand how much stock of biomass is there as fodder for the fire, so understand the risk of the fire, as well as understanding the extent and the frontier lines of the fire during the actual situation, so to help with the relief. And so we work with, in this case, the Office of Emergency Services at the state of California. Displaced people during flooding is another one. But I want to talk finally just about where we're going next, because I think it's really exciting. It's really, in simplified terms, space plus AI. We're adding AI to this. As with many fields, in fact, almost all fields, the advent of AI and the revolution that's happening in machine learning and computer vision is really making a phenomenal difference to what's going on. And the difference, as it is coming sideways to the space community and the Earth observation community in particular, is how we can index everything in each image. So if we take each image and just like Google and Facebook have figured out how to find cats and dogs in pictures, we use it instead for something slightly more useful, which is finding the objects in our imagery. So this is a plane, this is a train, this is a ship, this is a building, this is a road. Then we can basically build up a database of all the objects on the Earth over time, and then you can query that database. You could then just ask a question: how many houses are there in Pakistan? Give me a plot of that versus time. Or how many trees were felled in the Amazon between this month and last month? And can you just give us the latitude and longitude of those trees? And so instead of getting and looking at pictures, we're outputting what we call spatial information feeds. So spatial information feeds are where you might just say, hey, tell us the roads wherever it is. This is a case where we have done automated road detection and building detection, and in this case showing the buildup of a refugee camp in Syria. But it can be used anywhere in the world, and basically then you could just say, in this region, tell me where the roads are, and tell me when there's new roads or new buildings or things like that. Or in this little, as this little video demonstrates, you could just put a little ring around a port and just say, instead of showing me all the images of that port, just tell me when there's a ship, or just tell me when there's ships between these dates, or between these length scales. And I only want to know the number of ships in these ports between this length and this length over time. And then that's exactly what this does, and it spits out not just the pictures, but a database of the latitude and longitude of those ships, the size of those ships, and so on. And we're trying to do this more generically to create these spatial information feeds that would then plug into people's workflows. So that's really the future. At the present time, we're really providing satellite imagery, but where we're going as we're leaning on these fantastic AI developments that kindly many companies like Google are open sourcing, and the academic community is open sourcing, we are applying those algorithms to the millions of images that we get down each day to translate them into these spatial information feeds of what's on the planet. This can be customized to your specific workflow. So I guess I just wanted to leave you with the question of, what would you do if you could track changes and set up one of these spatial information feeds for your business? And with that, I will say thank you very much for listening, and I welcome any questions during the discussions, and some of my colleagues are here. Maybe you can just raise your hand, so if you want to ask me or them any questions during the break, we'd be happy to chat to you about getting access to some of the satellite data. Thank you very much for your time.